Myself, Muniraju Naidu, Assistant Professor, Department of Computer Science and Engineering, Institute of Aeronautical Engineering, Hyderabad. So today we are going to discuss about data link layer. What is data link layer? What are the various services provided by the data link layer? And what is the functionality of data link layer? What are the various protocols at data link layer? See, this is the overview of data link layer. We know data link layer is the second layer from the bottom point of view on OSI reference model. So we know the data link layer itself acts as a intermediate layer between physical layer as well as the network layer. So the data link layer is one of the most complicated layers which has complex functionalities. So in general, we know the basic concept of OSI reference model. Always the physical layer communicates with the physical medium and it extracts data in the form of the bits, zeros and ones. So whatever the bits extracted from the physical layer, the data link layer accepts that particular information and converts those bits into the frames. So the data link layer which hides the details of underlying hardware and represents itself to the upper layer as a medium to communicate. So because the network layer doesn't know that what is the hardware used at the physical medium or physical layer. Just the data link layer accept information from the physical layer and transport that particular information to the network layer. So this data link layer works between the two hosts which are directly connected in some sense. So we know generally in OSI reference model, the bottom three layers, those are communicated directly between various nodes. So according to the data link layer perspective, this communication, we can call it as the direct connection, may be either point to point or broadcast. But whatever the nodes which are available on any broadcast network, those are said to be on the same link. Another important point, the working of data link layer which tends to get more complex when it is dealing with the multiple hosts on a single collision domain. So that will be described in the later videos. And this data link layer which is responsible for converting data stream to signals bit by bit and send those signals over the underlying hardware. So whatever the information the data link layer accepted, that particular information which is converted into the signals bit by bit. Similarly, at the receiver end, that is at the destination end, the data link layer picks up that particular data from the hardware, from the hardware in the sense that particular data may be either in the form of the electrical signals and assembles that particular electrical signals or data in a recognizable frame format and provides those frames to the upper layer. So simply say that the data link layer is the second layer according to the OSI reference model from the bottom to top approach. The data link layer, which accepts information and provides that particular information to the upper layer. So the data link layer works between any two hosts which are directly connected. The particular direct communication may be either point to point or broadcast. Then coming to the next one, the functionality of data link layer. See, whatever the layer which is available on OSI reference model, that particular layer provides some functionalities to the upper layers. Similarly, the data link layer also provides some functionalities to the upper layer like framing, addressing, synchronization, error control, flow control, and multi-access. Next one, important one, what are the various design issues of data link layer? What are the various design issues of data link layer? So these design issues may be categorized into either services or protocols. So the data link layer which always places in between physical layer as well as the network layer. So what are the various services provided by the data link layer to the next upper layer, that is network layer? First one is an acknowledged connectionless service. An acknowledged connectionless service. Second one, acknowledged connectionless service. Third one, acknowledged connection oriented service. And what are the services? It accepts from the physical layer. That is unreliable bit transport. Unreliable bit transport. So what does that mean? An acknowledged connectionless service. You know the basic difference between connection oriented and connectionless services. In case of connection oriented, before actual data transmission is done, these two nodes, that is source node as well as the destination node, must be connected. That is, which establishes a connection. Once the connection is established, then only the actual data may be transmitted from the source to destination. Once whatever the data received from the source to the destination, then the destination transmits acknowledgement to the source node. So that is the actual connection oriented. Whereas in case of connectionless, there is no direct communication between the source as well as the destination. So the source transmits data. That particular data may be transmitted through some intermediate nodes, and that particular data may be reached to the destination. But there is no acknowledgement from the receiver to the source node. Is it right? So that is a connectionless. Unacknowledged connectionless, acknowledged connectionless, acknowledged connection oriented services. See, these are the various services to the network layer. Then there is a slight difference between connectionless service as well as the connection oriented service. What is the difference? Observe here, unacknowledged as well as the acknowledged services. We have unacknowledged connectionless service and acknowledged connectionless service. What is the difference? In case of unacknowledged connectionless services, whatever the data the source node transmitted in the form of the frames, those are independent frames. Because that is connectionless as well as unacknowledged. So there is no need to establish a predefined path before transmitting any particular data. So those are independent frames. Automatically what happens here? The error rate also less. The error rate should be low, but the recovery which is left to the higher level layers only. If any frame is missed, then the source node doesn't know that where that particular frame is missed. Similarly, the destination node doesn't know that how many frames are transmitted actual data transmission from the source node. Is it right? So recovery which is left to the higher layers. In general, this unacknowledged connectionless service used most of the applications used on local area networks. Then coming to the next category, acknowledged connectionless service. Acknowledged connectionless service. So we know acknowledged connectionless service. Here there is no acknowledgement for each packet, and the resending is possible, and then the acknowledgement is optimization. That means which is also the transport layer can handle the errors. Then connection oriented service. Connection oriented service, acknowledged connection oriented service. We know that the basic principle of connection oriented service, before actual data transmission is done, there must be a path between source as well as the destination. So what happens? For each and every frame, the receiver node may transmit one acknowledgement. So according to the data link layer, in case of acknowledged connection oriented service, each and every frame received exactly once. Right? Whatever the frames received in the right order, for that particular frames only the receiver node may transmit the acknowledgements. So for any connection oriented service, particularly acknowledged connection oriented service, we have three different phases. You know the basic principle, right? Request, use, release. Request, use, release. So how it is adapted to the computer networks? For connection oriented service, first phase is establishment of connection between source as well as the destination. Second one is data transfer. Once the connection is established, then the actual data may be transmitted from source to destination. Third one, after successful transmission of data, third step is release of connection. So that particular release, maybe we can call as a normal release or abort the connection or suspend the connection. So these are the basic differences between acknowledged as well as the unacknowledged connection oriented services and connectionless services. So these are the basic services provided by the data link layer to the upper layer, that is the network layer. Another one is framing and link access. See, these frames are encapsulate datagrams into the frames, which add some header as well as the trailer, because the original content, whatever the transmission medium we are used, that particular transmission medium carries the original content. In addition to that, it encapsulates that particular datagram into one particular frame. That particular frame is having header as well as the trailer. So we know this data link layer, which is having two sub layers, logical link control and MAC, medium access control. So the MAC addresses used in frame headers to identify the both source as well as the destination. This particular MAC address is different from the IP address. Is it right? So the MAC address, the purpose of MAC address is which is used in frame headers to identify both source as well as the destination. So what is the purpose of link access here? That may be either point-to-point or broadcast link. The reliable delivery option between various adjacent nodes is done with the help of that particular link access. Next one, flow control. We know flow control, which is always important in any particular network, that may be either wired or wireless. So what does that mean actually, flow control? Let us consider the source node is having high configured system when compared to the receiver node. Let us say the source node, which transmits 1 GB of data per minute, whereas the destination node is unable to receive the 1 GB of data per minute because the destination node configuration is low. That is, the source node is having 8 GB RAM, whereas the destination node is having 2 GB RAM. But what happens? Whatever the data transmitted from the source node, that particular data may not be lost. So we need to control that particular flow from the source node. So the flow control is placing between adjacent as well as the sending and receiving nodes. Then next service, that is error detection and error correction. So these error detection and error correction are very important in data link layer. So we'll discuss in the next class. But the error detection, we know what is meant by error. Why errors are occurred. On any medium, whether that is connection oriented or connectionless, there may be a chance for errors. The errors caused by signal attenuation, noise, receiver detects presence of errors. There may be signal sender for retransmission or any frame is dropped. So there are number of reasons for errors. But we have to identify those errors and we need to detect those errors and we need to correct those errors. Error correction. Here the receiver identifies and corrects bit errors. Whatever the errors which are occurred, those errors are identified and corrected by the receiver without resorting or retransmission. Then important one is half duplex and full duplex. You know what is meant by half duplex and full duplex? With half duplex, whatever the nodes which are in communicating, the nodes at both the ends of link can transmit but not at the same time. Whereas in case of full duplex, nodes at both the ends of link can transmit at the same time. There is a slight difference between half duplex and full duplex. Next one, where is the data link layer is implemented, right? So basically the data link layer which is implemented in each and every host. Where? The link layer which is implemented in adapter, which is called as nowadays we can call as a network interface card. NIC, network interface card. So there are number of variants like Ethernet card, that is IEEE standard 802.11 card. And this particular data link layer which is implements link as well as the physical layer. See, in this particular representation, within that particular system, processor, memory, as well as some controllers, right? So these controllers, that is we can simply call it as a network adapter card. Network adapter card, how the network adapter card which is communicated to the processor as well as the memory, means with the help of the PCI, peripheral component interconnect, right? So just like you imagine your cabinet, right? So we have one port for inserting your LAN cable at the back panel, but how that particular network interface card which is attached to the motherboard and how that is communicated with the processor as well as the memory. So that's why the basis for this computer networks is computer organization and architecture. We can call it the prerequisite for computer networks is computer organization and architecture. So all these concepts already we learn from computer organization and architecture, right? So in this way the data link layer which is implemented, see here, that is the basic organization as well as architecture. According to our computer networks, how the layers are communicated to each other. See in this diagram, the bottom level is physical layer, next one data link layer, network layer, transport layer, application layer, right? So that is the link layer which is implemented in between network as well as the physical layer. So this is the way how the data link layer is implemented. Right? Next, coming to the design issues of data link layer. Among those, another design issue which is related to the protocols. So coming to the, where is the position of data link protocol? Position of data link protocol. See, this is the communication happens between source as well as the destination. So for understanding purpose, let us consider host 1 and host 2. Host 1 acts as a source, host 2 acts as a destination. In between, that means the host 1 and host 2 communicated with the help of 4 routers, namely router R1, router R2, router R3, router R4. So we know from the OSI reference model, the bottom 3 level layers, that is physical layer, data link layer and network layer. So these 3 are communicated through some medium, right? See, actual protocol data unit, PDU stands for protocol data unit. So how the actual protocol data unit flow will occurs? See, from the source node, that is host H1, the data link layer of host H1 which is communicated to the router R2. Router R2. So within that router R2 which is also communicated to the same data link layer. Right? So similarly, each and every router communicates with the help of the data link protocol. So there are number of data link protocols. In the next session, we will discuss in detail about that data link protocols. Right? So in this way, whatever the data may be transmitted through various routers, that particular data may reach to the destination, that is host 2. Is it right? So this is the position of data link layer. Right? See, we know the physical layer transmits data in the form of the zeros and ones, whereas data link layer in the form of frames, and data link layer to the network layer, the data is transmitted in the form of the packets. See here, this is one particular router. This is one particular router. Within that particular router, how the actual data may be transmitted. See, this is the frames are transmitted. This is data link layer process. Then here the packets are transmitted. So here the routing process is completed. Right? So this is according to one particular router. How one router may be communicated with the another router in the same reverse way. Right? See here, this is the data link protocol. Whatever the data link protocol we are using, that is the data link protocol. Here, again physical layer, data link layer and network layer. Right? So this is another transmission line to some other router. This is one transmission line to this particular router. This is another transmission line to, this is another transmission line to some other router. This is transmission line to some other router. So this is the transmission line to this particular router. So this is the position of data link protocol. Right? So in addition to that, these are the various design issues of data link layer: framing, error control and flow control. We know in simple, framing means the break stream of bits into the discrete frames. The physical layer which is transmitted data in the form of the zeros and ones. Once this particular data is transmitted to the data link layer, then the data link layer converts those streams into the frames. So one particular frame, this is one particular frame. So this is another frame. So framing means break stream of bits up into the discrete frames. Error control means, next one, error control. How does a sender knows that all packets are correctly received? How does a sender knows that all packets are correctly received. That specifies the error control. There are a number of mechanisms to identify that error control as well as the flow control. Next one is flow control. How to prevent a sender to overload the receiver with packets. So already we discussed this error control and flow control. Flow control means how to prevent a sender to overload the receiver with packets. So these are the various design issues. Among those design issues, coming to the first one, framing. We know framing means break stream of bits up into the discrete frames. So what are the various methods for framing? First one is that is the earlier method, that is the use of time gap. Use of time gap, that is unacceptable as well as the too risky. Second method for framing, that is the character count. Third one, starting and ending characters with character stuffing. Fourth one, starting and ending flags with bit stuffing. So in computer networks, the framing is done either character stuffing or bit stuffing. These are the two mechanisms which generally used by any application. Then physical layer coding violations. Physical layer coding violations. So these are the various methods for framing. See the first one, character count. See the first one, character count. Because in case of framing, you know the frame which contains the length, or we can call it as a characters. See here, let us take this example. Frame 1 which consists of 5 characters, those are 5, 1, 2, 3, 4. So up to this frame 1. Then 5, 6, 7, 8, 9. So up to this frame 2. Then frame 3 which consists of 8 characters. Frame 3 which consists of 8 characters. Frame 4 which consists of 8 characters. So here the character count is done by each and every individual character. Right? See what happens whenever we need to transmit this particular frame which contains these many number of frames as well as the characters. See the frame 1 which contains the same characters 5, 1, 2, 3, 4, 5, 1, 2, 3, 4. So up to this correct. Then frame 2 which consists of 5, 6, 7, 8, 9. Here, see here, in place of 5, here the 7 may be transmitted. So 7, 6, 7, 8, 9. So this will shows the error. What happens? The frame 2, that is a wrong frame, may received by the receiver. Now from here, now a character count takes place. So that is out of synchronization if error occurs. That is a character count. But this method is rarely used. There are a number of drawbacks because you know, in general, whatever the transmission medium, there may be a chance for errors like noise or attenuation. There are a number of parameters. Then character stuffing. Character stuffing. So we know stuffing, adding something. Where? See, the frame starts or ends with a special sequence of characters. Frame starts or ends with special sequence of characters. See, let us take this is my frame. So I need to represent DLE starting. So these are the characters A, B, C, D. Then DLE end text ETX. So the frame starts or ends with a special sequence of characters. Those special sequence of characters, those are DLE as well as the STX. Similarly, frame ends with special sequence of characters, DLE as well as the ETX. So, allows all the characters as data in the frame. No, here character stuffing, additional DLE before each and every DLE. Right? How? See here. A, DLE and C. DLE, starting text, and my characters A, DLE, DLE, C, DLE and ETX. So the character set which represents here DLE, data link escape, data link escape, STX, start text, ETX, end text. So character stuffing. So we need to add some special sequence of characters before and after actual data. Right? So that is specifies the character stuffing. See, this particular character stuffing which is used by some latest protocols, where rather than using this DLE as well as the ETX, there we can use a flag. See, this is the header format for character stuffing. Flag, header, payload field, trailer, flag. You know, payload field, that is the original content, whatever the content we need to transmit from source to destination. So in addition to that, header as well as the trailer, which consists of some character stuffing, that is flag as well as the header, flag as well as the trailer. See, let us take this example. Original characters are A and B. A, flag, B. So after stuffing, after adding, so we need to add escape before the flag. Then for each and every character, we need to add escape A, escape B. So like this, for our application point of view, here we need to add some more flags according to our requirement. Then bit stuffing. Right? So here the special bit pattern may be used for start as well as the end of each and every frame. What is that? Whatever the original content, for that add 0 after 5 consecutive ones. Add 0 after 5 consecutive ones. So this is your original data. See 0, 1, 1, 0, 1, 1, 1, 1 and so on. Right? See, according to the requirement, add 0 after 5 consecutive ones. See, 5 consecutive ones are there? No. 1, 2, 3, 4, 5. So, after this, here I need to add 0. See, 1, 2, 3, 4, 5. So, this is 0 will be added. Then, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, again, I need to add one more 0. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Again, I need to add one more 0 here. This is 0. This is 0. Right? See? 1, 1, 0, 0, 1, 0. 1, 0, 0, 1, 0. See, this is a 1, 0, 0, 1, 0. So, these are the newly added bits. We can call as a stuffed bits. Right? So, at the receiver side, it receives same as the source. See, we need to remove that particular stuffed bits. 0, 1, 1, 0, 1 and 1, 2, 3, 4, 5. Once again we need to remove this 0. So 1, 2, 3, 4, 5. Again we need to remove this 0. 1, 2, 3, 4, 5. So 0, 0, 1, 0. So that is a bit stuffing, right? Right? So that is a special bit pattern for each and every start as well as the end of the frame. That is a starting bit we can call as a most significant bit is 0 as well as the least significant bit is 0. Remaining 6 bits are ones. Then last category, that is a coding violation. So the redundancy in the encoding on medium, that is required. The best example is Manchester encoding. Manchester encoding. So here the transition is in the middle of a slot. So let us take one example here. The bit stream is 100 00 00 10 11 11. Right? So the binary encoding, zeros and ones. So the binary encoding is looks like this. So 1, and for zeros, that is off. 1 means on. 0 off. 1 means on. That is the binary encoding. Whereas the Manchester encoding, here each and every bit, what is a transition? That particular transition is divided into the equal parts. So a transition in the middle of a slot. See, this is the middle. So Manchester encoding is looks like this. See, this is 1. 1 means on. So on and off. Again 0. Always off means off and on. Off and on. Off and on. Until again 1 is reached. On and off. Again 0, off and on. So like this. So this is the Manchester encoding. Right? So this is another mechanism in case of framing, that is a coding violation. Then error control. Error control. How does a sender knows that all packets are correctly received or not? So that's why in case of data link layer, we used both sequence numbers as well as the acknowledgements. Sequence numbers. What is the purpose of sequence numbers? So whenever the sender transmits some 10 packets, data packets or 10 frames, so each and every frame is having one sequence number. Frame 1, frame 2, frame 3, like that. Right? So if any frames doesn't reach to the destination node, then based upon the sequence numbers, the destination node can easily identify that which frames doesn't reached. So how does the sender knows that all packets are correctly received? So that is a acknowledgement packet by the receiver. So that's why we have to maintain in data link layer both sequence numbers as well as the acknowledgements. Then another way of error control is packet loss or not recognized at the receiver. Packet may be lost or not recognized at the receiver. For that, here we need to maintain some timers at the sender side. Right? So based upon the type of data in my application, I need to set the timer. Right? So this is, for example, my application is always carries only Word files. Then I need to specify that only 10 seconds for 100 MB data. Within that particular 10 seconds, 100 MB doesn't transmit from sender to receiver, then automatically the data may be lost. Is it right? So I need to maintain my application like that. So the packet lost or not recognized at the receiver, timer at sender. If within that particular time, the packet doesn't reach to the destination, what happens? Again, the source node again resend that particular packet. So there is a drawback here. There is a chance for duplication of packets at the receiver side. Then how to handle duplicate packets or out of order received packets? That's why here we need to maintain the sequence number in packet as well as the acknowledgement packet. Right. So if the receiver node receives after some time, that is after 10 seconds, the receiver node receives, for example, the packet 1. So meanwhile, what happens? The receiver node send a acknowledgement to the sender. Hello sender, packet 1 doesn't reach. What happens? Again the sender node transmits the packet 1. But meanwhile, the packet 1 is reached to the destination. So with the help of sequence number, the destination machine can accept or reject that particular newly arrived packet or not. That's happening only with the help of the sequence numbers. Then optimization. Optimization is possible with a negative acknowledgement packet. Right? So what is the purpose of negative acknowledgement here? Which informs the sender that something strange happened. Right? That means without receiving the data packet, how the destination node may transmit the acknowledgement. So there is a chance for negative acknowledgement. So these are the various mechanisms for error control. Right? Then flow control. We know how to prevent a sender to overload the receiver with packets. By default, the receiver gives some permissions to send more packets. That means if the receiver is capable of receiving all the data packets within the stipulated time, then automatically the receiver gives permissions to send more packets. Okay, I am ready. I am capable of receiving whatever the data packets from you. Then what are the various mechanisms for this particular flow control? Implicit mechanism as well as the explicit flow control. Implicit as well as the explicit. Implicit means here the acknowledgement packet implies permission, whereas explicit means communicates the window size. Right? So there are some algorithms for this flow control according to the data link layer. We will discuss in the next sessions. Right? Thank you. So today what we discussed, what is data link layer, what is the purpose of data link layer, where the data link layer is implemented, what are the various services provided by the data link layer, and what are the various protocols provided by the data link layer. Right? Thank you. Have a nice day.
Like, share and subscribe. Hit the bell icon for more updates.